Welcome to our statistics class, where we're going to solve statistics problems. And we're going to look at assorted questions. We'll start with the easiest ones. We'll go to probability. Now, probability can be very easy and very tough if you don't understand anything. So to start with, I'll just look at four formulas. Number one, the probability of an event A is simply found by enumerating the observations that A has over the total events that are there in the experiment. So meaning the complement of A is simply 1 minus A. So if A is 20%, the complement is 80%. Is that clear? Then we have a union set formula. This is the most faithful formula. To unite is to add. So A union B, the word union may come in the word or. So whenever we are uniting, we are simply adding. So the probability is given as follows. You add what A and B have, then you subtract the intersection. So it also follows that if we're going to make this subject of a formula, we're just shifting things. This guy comes here and this guy comes there. So the same formula gives us A intersection B is equal to the same projection. We have A plus B minus what? The union in this case. So this is just a manipulation of the same formula. Are we together? All right.
Yes, we are.
Then we go to conditional probability, which simply says A given B must be equal to, you bring down the B down there and intersect the letters that are available. We usually start with the letter that comes first in the alphabet, but there's no harm to interchange them. So this therefore means that when you cross multiply these two, our A intersection B will therefore be equal to probability of B, probability of A given B times the probability of what? B. Now I call the intersection a prostitute formula because it varies depending on the data that you're given. Intersection means end. And whenever we're intersecting, we're multiplying. Any questions so far?
Just can you shed more light on the second part, the one in red that you've done?
Okay, your question is, I shed more light on just what is in red.
On the yes, what is in red? Because I understand that the first part is conditional probability.
Yes.
Yeah. So then the second part is which aspect of conditional probability is it?
So this is conditional probability. Whenever we see a slash, this is read as A given B. So A given
Yes.
B, we bring the B down there. Then we intersect A. In short, convert this slash now into an intersection. So when you cross multiply here, there's a 1 there. 1 times A intersection B is A intersection B. A given B times B, we're going to have that. All right. So this gives us another formula for intersection. Intersection has about 5 formulas. So this is where most people are thrown out. They don't know when to use. All right. So tell me, help me expand this. Suppose we're given B given A. Somebody help me expand this. B given A, what do we have?
I think it becomes probability of B given A multiplied by probability of A.
So what just happened here? B given A. The first thing, take the bottom guy down there. All right. Then intersect the letters. Here you can write B intersection A or A intersection B. All right. Then you cross multiply. A intersection B times 1 is A intersection B. Then B given A times A. So you can see the pattern is, if you have B given A, the bottom guy should be the multiplicand. We have A there. That is the only way we're going to have an intersection. So already we have formula number 3 for the intersection. Then we have theorem 1 for the intersection. If you don't have conditional probability, you're just given A and B. To find intersection, just multiply the probability of what? A times the probability of what? Of B. Sharp one. But it's a dangerous formula because some people will be lazy to use it. You only use it if you're not given any other information. So this is theorem 1. All right, are we moving together?
Yes.
All right. I'm taking my time. So that everyone is on board. So now I'll go to the conditions, the 2 conditions. So there are sometimes when we have conditions to be independent, it means that you're not affected by anyone. You're free. So independent, A given B must go to A. So meaning regardless of what letter is there, the top guys still exists. B given A must be equal to what? B. All right. So O will be independent. The intersection of A intersection B must be equal to when you multiply the probability of A times probability of B. So that is a condition. They'll ask you, are these events independent? So you need to test using this condition. Then to be mutually exclusive, it means you can't exist. There's no intersection. Mutually exclusive simply means the intersection of A and B is equal to 0. So we have nothing in common. So mutually exclusive events are events which are disjoint. They not meet. You can't be male and female at the same time. All right, so the intersection is empty. All right. So firstly, I had to take you through these axioms before I take you to the questions from the tutorial sheet. So now let me ask if there are any questions. All right, so let me start with a basic example. If you have A, you have B, we have X, and we have Y. And we have 2, 4, 6, and 8. So whenever you're given such information, the first thing is you total up. What is the total for B?
10.
Okay, let me just put them.
It's 10.
Okay, 2, 4, 6, and 8. The total for B is what?
8,
Y,
12,
12.
A,
6,
and X, 14.
14,
And what is our total?
20.
20.
20, correct. So now if you're asked to find the probability of A, remember, it's how many A's we have, the number of elements we have as A, over the total number of events. So what are we going to have?
6 over 20.
To understand how we're getting the numbers there.
Now we're getting the number. So 2 plus 2 is 6. 6 plus 18 is 14. Then we go here. 2 plus 6 is 8. 4 plus 8 is 12. Then the total this side and the total this side must always tally. Is that clear?
Yes.
The probability of A is 6 over 20 is 0.3. So now help me, probability of B.
8 over 20.
8 over 20, which is what? 0.4. Then Y,
12 over 20.
which is what? 0.6.
6.
And X,
14 over 20.
I hope you all have your calculators so that we move fast, which is 0. What?
0.7.
7, good. Anyone behind at that point? All right. So we go to the intersection. Intersection A intersection B, where they meet A and B. You do a plus. They meet at what? At 2. So 2 over 20, which is 0.1. So intersection means out of the total events. How about X intersection Y?
8 over 20.
Good, then at 8. 8 over 20. Which is 0. What? 0.4.
7. Oh, 0.4.
Are we together? Is anyone behind? Okay.
The way we are picking the numbers here,
Mhm,
is it that, for example, I think the question and asked that you had given the 2, 6, and 8, isn't it?
mhm.
You had presented it, isn't it?
Yes.
And then you also presented Y numbers, isn't it?
Mhm.
And then we calculate,
The totals.
we did sum up
Mhm,
both sides,
mhm,
where we got 6, 14, 8, 4.
mhm.
Hello.
But then I think
Mwanisaba muli
by
manzi
the
maningi
challenge I'm
mapakisa
having,
manzi
when it comes to the formula here,
So the formula simply says the number of elements of A over the total events. So A, how many are they? The total, there are 6. The total events, how many are they? There are 20. B, the total events for B is 8 over the event sum total is 20. Intersection, just where they meet. A and B, they meet at 2 over 20. X and Y, they meet at 8 over 20. All right. You can use the formula if you want. I'm trying to simplify this as far as possible so that you don't think twice. Now help me find the union of A, union B. Who remembers the formula?
Probability of A plus probability of B minus probability of A intersection A intersection B.
Excellent. A plus B minus the intersection. So what was our A?
.3,
B,
0.4,
intersection,
0.1.
correct, and the total is 0.6. The gents, can you give us a projection of X union Y? A bit of X plus, help them.
Y
Equals
minus
probability
B
minus
in,
X intersection Y.
X Y.
What was our X?
0.7.
14.
Y 0.6.
The intersection,
0.4.
all right. So we get 0.9. Are the events A and B independent? Are they mutually exclusive? To be independent, who remembers? A intersection B must be equal to what? A times B. Okay. How about to be mutually exclusive? A intersection B must be equal to what?
0.
Excellent. So let's find out whether they're mutually exclusive or they're independent or they are neither. All right. So you need to understand the rules. Then that is when you can apply them. So whenever I look at the conditions, first thing is you state the condition, then compare the figures, then you conclude. So let's start with independence. So independence, A intersection B must be equal to what? A times B. So what was our A intersection B? A intersection B was what? Intersection B, what did we get? 0.1. And probability of A was 0.3. And probability of B was 0.4. So when we apply these two, what are we getting? 0.12. Are they the same with 0.1? No. So your conclusion will be not what? Not independent. Question. What word can we use in place of intersection?
And
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 or even if they say AB, there's an invisible and there. Okay. A male footballer is male and is a footballer. What is the other term for union?
or
Oh,
Or.
excellent. What is the condition for mutually exclusive? A intersection B must be what?
0.
0. Yeah.
But our intersection was 0.1. Are they the same? They are not. So
No.
conclusion that they are not mutually exclusive. Right. So now let's tackle this question. As we do these questions, you're on record, don't embarrass me. I've taught you as it should be. So I'll just quickly need you to answer as they are. So there are about 4 questions here. So let me just beam them here. So if a gentleman answers, we go to the ladies. The ladies answer, we go to the gents. So we have new and used. And here we have SUV and sedan. And we're given the figures as follows. 24, 15, 9, 12. 24, 15, 9, and 12. And we have the questions given as follows. So let's help each other. Okay, so the first thing we do, Maggie, before we do anything, what do we do? What do we do when I give such a question?
We sum up the numbers.
Get the totals correct. Can you help us sum up the numbers?
24 plus 9, 33.
Mm-hmm. Help her quickly.
27,
7, correct.
27,
Here,
89,
37.
39. Here,
and 21.
21.
1. And what is the total of totals here?
60.
60. Okay, before I go to this, sorry, let me go back to the example we're doing here. I forgot one more thing. Let me just rush you through. If you're asked to find the conditional probability A given B and B given A, so remember the intersection, we're using the total of totals, but if we're using the conditional probability, for instance, A given B, I'll use 2 methods. A given B, the formula is what? Down we have what? Probability of B. Then on top, we have A intersection B. All right. So our A
Mhm.
intersection B was 0.1. And the probability of B was 0.4. So when you compute that, 0.25. Okay. Alternatively, you just go where they meet A and B. They meet where? At 2. But go to the total for the bottom guy. So the total for B is what? 8. So you're going to have 1/4, which is 0.25. If the opposite was given, B given A, using the shortcut, they still meet at 2, but this time the total for A. A, what is the total? It is a 6. So you're going to get 1/3. So you're going to get 0.33. There's no harm. If you want to use the formula, you still get the same answers. Are we together?
Yes.
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 So now tell me, you're being a very good class. So what is X given Y? Please, if anyone is behind, you can start the whole class all over again for you.
X given Y is 8
So they're meeting where? At
at
8,
8,
at the total for what?
which is 12. Total
Y.
for Y is 12.
Excellent. So what do we have there? 4 and there 2, 4 and there 3. So 0.67.
Hello, sir.
Yes, sir.
Yes, I'm quite behind on the intersection. How are you coming up with the numbers to say they're meeting here, they're meeting there?
Okay, that's a good question. Brian, can you help us? How do we know whether they're meeting? How do we find this?
Okay, so for we look at the probability of X given Y. So when you go to X, there's yes, when you go to X, then you go towards the right, which is horizontal, then you go to Y as well. So where the two numbers meet, the number that is there, that is 8. That's the 8 that we get. Then you get below, so you divide it by the totals of the figures that fall under Y. So under Y, there's 4 and there's 8. When you add them, the total is 12. So you divide 12 into 8 and gives you 0.67.
Excellent. Now, Brian, explain to him, suppose it was swapped, Y given X.
So if it's Y given X, okay, so Y given X, they are meeting on, okay, so if, let me start with the earlier formula first. Probability of Y given X would be, probability of Y intersect X over probability of X. So that would be the first formula that we can use here. Probability, yeah, then meaning we'll have probability of Y intersect X. So we get the probability of X of Y, that would be what? Y intersect X, that's 0.4?
0.4, yes.
Yes, 0.4 over probability of X. What was the probability of X that we found earlier?
0.7.
0.7, then you divide. Is it?
Okay, when you divide, what are you getting?
Let me just get my calculator. 0.57.
0.57. Correct. All right. So the shortcut, how do we use the shortcut?
Okay, so the shortcut now is that, so probability where y and x meet would be 8. So we still get 8. Then we get the total of x, which should be 14.
Are we getting the same answer?
Yes, the answer is the same.
All right. Thank you so much for that. Now let's go to our tutorial question. Yeah. So we are given this, we have done the totals. Can I have a lady to help us determine the probability that a car randomly selected is new? What are we asked to find?
The probability that the selected car will be new.
Since the total for new is 39, so the probability 39 over total 60. So when we divide, we get 0.65.
So new. Okay, she says the total for new is what? 39 over
39.
everything. 60, which is 0 point what?
65.
Ladies, do you agree with her?
Yes, we do.
Yeah, the formula is okay.
All right, the gentleman. The second part.
Determine the probability that a randomly selected car is a sedan. So the total for sedan is 33. So we do probability, so we do 33 over 60.
Which
So
is
33 over 60.
0.55.
0.55, good. Okay, the ladies, probability. The car is a new sedan. What are we looking for?
Probability of sedan and new.
New sedan, so what word is in between?
24. Sorry?
What word is in between these two?
And
And
And,
Yeah.
and what symbol do we use for and?
intersection.
Intersection, correct?
But where is the and coming from?
Where is the and coming from? There's a question there.
Just saying the probability that a randomly selected car is a new sedan.
Yeah, so it must be new and must be sedan.
Ah, okay.
So I made mention.
Hello, Mr. Collins.
Yes, please.
Yes, I just kindly shed more light on this one because my understanding is that the question is saying determine the probability that a randomly selected car is a new sedan. Maybe just shed more light why we are using this.
So I made mention to say grammar here. Whenever you have A, B, or a male footballer, there's an invisible and that is there. Okay. It should be new and it should be a sedan. So even if it's not there, we assume the word and is what is here. A male footballer should be male and a footballer. Or
So
cannot.
it's a so it's called, is it the same as saying probability given that the randomly selected car is new?
Yes.
Or given probability of a random selected car is new given that it's a sedan?
No, that one is conditional. If you see given, there's a slash.
Oh, okay. The new, it's just intersection.
Okay, ladies, continue.
Be 24/60.
which is what?
Zero point four.
0.4.
0.4. Okay. Then the last one, the gents.
Okay, so the last one is addition.
Okay. How did you
Yeah,
know?
so
addition?
there is the or there. It's used
Mhm,
or
correct. So O is the same as the union. So how do we expand this?
so we have probability of used,
Mhm,
probability of SUV
mhm.
minus probability of where the intersecting. That is used intersection SUV.
Excellent.
Mhm.
So what is probability of used?
Probability of used 21/60.
1/60, correct. Then probability
SUV
of
27/60.
7/60, correct. Intersection
12/60.
12/60, excellent. The denominator is the same, just deal with the numerators. So just add 21 plus 27 minus 12, what do we get?
Eighty-six.
Confirmed,
Yes.
which is equal to what?
0.6.
0.6, do we agree?
Yes.
All right. Anyone left behind? Please speak now or forever hold peace.
Kindly just repeat on that one, Mr. Collins. How have you subtracted 12/60?
The denominator is the same, so you just add 21 plus 27 minus 12.
So I think maybe just an explanation is that to the gentleman, why we've subtracted 12/60 is that when you look at the formula, so probability, when we're using O, the addition rule is the probability of probability of A plus probability of B minus probability of A intersect B. So the last part that is being subtracted, we are looking at the probability of used intersect SUV. So the 12 is where the used in the SUV meets. When you look at it diagonally from used all the way up to SUV meets the vertical, it's 12. So the probability of where they meet, which is 12, over the total number of the vehicles, which is 60.
Okay, thank you.
Why are we dividing everything by 60?
To
60
come
is
from the formula.
60 is the total number of
The
the
total
vehicles.
number.
And when you look at the formula, so if you're going to find probability of going to find the probability of the used vehicles, the total number of the used vehicles is 21. So you divide by the total number of the elements, which is 60, which is the basic rule of probability. The total number of over the, you divide the total number by the elements that is in question. Similarly, over the 27 is the total number of the SUVs. So you divide the total number of the SUVs over the total number of the elements, which is 60.
Okay, so how do we know the total number is, like the total number of the elements is 60? Is it in the question or what?
No, it's not in the question. It's not in the question, but it's on the graph. Remember when we were given the graph earlier, the totals were not there. So like Mr. Collins had indicated, I think we only had 24, 15, 9, and 12. So the first rule is for you to get all the totals. So for the new vehicles, you add the 24 sedans and the 15 SUVs. So that gives you 39. The used vehicles, there's 9 sedans and SUVs that are 12. Total, it gives you 21. Then when you look at, then you also add the total number of the SUVs, it goes to 27. The total number of the sedans is 33. So when you add the total number of the sedans and the SUV, either way, whether vertically or diagonally, it gives you 60. So that number is supposed to balance. So if the
Okay,
number is
I
not there,
understand.
yeah, the number is not there, it will be, if the number is not there, then you create it by adding all the elements.
All right, thank you.
So impressed. All right, so I'll cruise through this one so that I cover as much as I can. So this question here, fortunately, you're given the totals. Now, the prerequisite for this course is English. You should have passed your English to understand probability. So we are told that the number of wins by 2 friends who are playing tennis is given as follows. We have people, Deb and Bob, and we have warm-up time with short and long. So Deb is 4 and 16, the total has been given as 20. Bob is 4 and 24. The total is 30. Short time is 10, long time is 40. The total across is 50. Question 1, find the probability that Deborah wins if she only has short time to warm up. Now the word if, the word assume, the word given, all these are synonyms of the conditional probability. So here we're told, find the probability that Deb wins if she has short time. So Deborah given short time. So the if translates into a forward slash. So Deborah given short time. So we go where they meet Deb and short time, that is 4. But over the total of the base, the short warm-up time, the base is what? 10. So 4 over 10 is 0.4. Then now this part 2 begins as follows, assuming Deb won. So you got to put a slash Deb, find the probability that the warm-up was short. So it's just a reciprocal of what we've discussed here. Assuming, even if we start with if, so the word preceding this if when must go down. So assuming Deb won, so slash Deb, find the probability that the warm-up was short. So short comes on top. So according to our shortcut, they still meet at 4, but this time the total for the base is for Deb, which is 20. So 4 over 20 is 0.2. Given that warm-up was short, so slash S, you put it there. Find the probability that Bob won the next match. So Bob comes on top. So where does Bob and short time meet? They meet at 6. But the total for the bottom guy, short, is 10. So we put 10 there. So 6 over 10 is 0.6. Assuming the warm-up was long, so slash long, find the probability that Bob won. So we put Bob here on top. So where they meet, Bob and long, is at 24. But the total for long is 40. So we have 0.6. Lastly, are the events Deb and long independent? So we know that to find this, we say the intersection of Deb and long must be equal to when you apply the probability of Deb and long. So you have to understand what's the probability of Deb? 20 over 50, which is 0.4. What's the probability of long? 40 over 50, which is 0.8. Then the intersection where they meet Deb and long, that is 16 over 50, which is 0.32. Are they the same answers? Yes, they are. So I'll repeat that with you now, step by step. An African mind understands the second time. So I was a little bit fast now. I want you to answer. Let me broadcast the questions here. Please, we have quite a lot of questions to cover. Exhibit intelligence. Keep telling your head, please, please, please. If you could pick up, perfect, pick up. All right, so the principle is simply the same. I just need you to understand that this is exactly what we were doing, except that we've advanced it a little bit more. Okay, so let me beam it here. Please, let's not take much of the time here. This is the last question I'm doing on what we call the contingency tables of probability. So we have short time. I'll use the and long time. Bob and what? This Deb and Bob. All right. Unfortunately, we're given 4, 6, 16, 24. So here, sometimes they'll give you the totals. All right, so this is 20, this is 30, this is 10, and this is 40. The total is 50. Let's start with the ladies quickly. Determine the probability that Deb wins the next match if she only has a short time. What do we do? What are we looking for, ladies? Come on, quickly.
Probability of Deb over D over S.
Okay, so probability. So we identify where there is if. So which letter goes under if?
S.
Yes, good. On top, we're going to have what? Deb. Do you agree with
Deb.
her?
Yes.
Yes.
Then what do we have? Where do we go?
Which is equals to according to our graph, Deb is 4.
They meet at 4.
Then we divide by the total 10.
10, the total for the short, which is 0.4.
Yes, correct.
Excellent. The gents, assuming Deb won the last match, that means the likelihood of a warm-up being short. So, yes. So, there's assuming. So, which one comes below the slash?
Short.
Short.
I wasn't seeing
What comes
them
on top? Short comes on top. So if you're putting short here, then on top you're putting Deb, easy, right? Easy, right?
No.
No, what's supposed to be?
No, Deb is supposed to be S given D.
Yes,
We have the condition.
Why? Because assuming is preceded by Deb. So where do they meet? Still in that 4. But the total for Deb, which is 20. All right. So how do we get 0.2? Next, the ladies, given that warm-up was what?
Let me try. 6. Okay, I should start with the formula.
Yes.
Is probability
Mhm.
I think is it Win Bob?
Which one comes down?
Which one do we start with? But I just know the numbers.
No, let's understand this. Given that warm-up was short,
We
there's no win. There's either short or the names.
Short comes down.
Bob
we're
is
short on top. Bob below.
yes, then down short. No, Bob is
B below. Okay.
Amolu.
Short here. Then Bob here.
Bob below.
No,
Mm-hmm.
No, it's the opposite.
we have the
Like this.
yes. Yes.
Ladies, are you agree?
Yes. Yes.
Yes.
The
So
short
given
is
short.
down.
So
So it
short
should
are
be
bunch.
6 over.
Mhm.
Yeah, it should
So where do they meet? 6 over what?
6 over 10.
Mhm. 0.6 what? 6. Okay, gents. Assuming it was long. Which one goes down?
Long.
Long goes down. And on top, what do we have?
Bob.
Bob, correct. Where do they meet?
24
Over
over 40. 40.
what? Correct. So what do you get?
0.6.
0.6. Correct. All right. The last one. Are these events independent? How do we know the events are independent? Probability of Deb. Section. What? Must be
Intersect long.
if they're independent. When you intersect them, you multiply them individually. It will be the same. So what is the intersection L? What? Then what is probability of D? 20 over 50 times what? Probability of L? 40 over 50. So when you multiply them, you're going to get 0.32 on both sides, which is the same. So you conclude that these ones are, in fact, independent. They're indeed independent. All right. Any questions before we proceed to something new? Any questions before we proceed to something new? Are we following? Are we able to relate?
Yes, sir.
Yes, we are.
All right. So we can now go to something basic. I'll be mixing the topics so that we can move from easy to tough to tougher. All right, so let's go to basic mean. Question number 1. So this question here, we have been given the following data. The following shows cumulative frequencies of the kitchen tabs obtained from preference of housewives. So those that loved a 1 meter, the cumulative frequency was what? 50. 1.5, 48. 2.0, 42. 2.5, 40. 3.0. So for you to understand this, you need to understand how to compute grouped data. So I'll briefly teach, like usual, just something quickly on how to find the mean. No, just the median and the mode. So I expect everyone here to participate. So from the classes that we have here, we're able to tell the height. So how do we find the height from the classes? The distance from here to here to here to there, or from here to here to here to here. The height there is what? 5. Don't subtract them, you get a wrong figure. Then cumulative frequency, you start with this number that you have here. You put it there. You add it to the 6 to get 10. You add it to the 8 to get 18. You add it to the 2 to get 20. This is called our n, which is 20. Now, ideally, these numbers must be the same in the diagonal. If not the same, you're going to subtract a 0.5 from the lower bound and add a 0.5 to the upper bound. So the upper bound is easy, just put a 0.5 there, 0.5 there, 0.5 there, say rule, 0.5 there. On these ones here, just subtract a 0.5. So instead of 1, we're going to have what? 0.5. Here instead of 6, we're going to have 5.5. Here instead of 11, we're going to have 10.5. Here instead of 16, we're going to have what? 15.5. Are the diagonals the same now? Yes, this number is the same as that number, is the same as that number. Suppose my numbers are 1 to 5, 5 to 10, 10 to 15. Is there any need of subtracting the 0.5? No.
No.
These numbers are already the same. So we call that adjusting the classes. All right, so what do we call this? This is called the lower bound. What do we call this number? The upper bound. All right, so can be able to illustrate what is called a histogram using the adjusted classes. You cut it here to show that we're not starting exactly from 0. Then you use these numbers using a 7. So we have 0.5, 5.5, 10.5, 15.5, and 20.5. I've forgotten 5.5. All right, then the frequency. Okay, we have these numbers as follows. The highest number is 8. So you can have 2, 4, 6, 8, 10. So from 0.5 to 5.5, it is a 4. From 5.5 to 10.5, it is a 6. From 10.5 to 15.5, it is 8. And from 15.5 to 20.5, it is a 2. So this is what we call a histogram. All right. So sometimes they'll ask you to come up with a relative frequency column. So we have RF and RCF. So how do we get? We divide 4 out of 20, 0.2. 6 out of 20, 0.3. 8 out of 20, 0.4. 2 out of 20, 0.1. Then for the cumulative, the way we're doing, you put this number here, you add up this one to that one, get 0.5. You add up this one to that one, 0.9. And finally, the cumulative frequency always ends at 100% or 1. So this is how to come up with what we call the relative cumulative frequency. This is what we call grouped data. So I'm explaining from what you already know. Any questions before I proceed? Please ask.
I'm lost on the 4 out of 20 being 2. And just shed more light on these calculations.
So these ones here, okay, the frequencies, we have 4, we have 6, we have 8, we have 2. The total is 20. Relative means subject to the total. So you divide this 20, 6 out of 20, 8 out of 20, 2 out of 20.
Okay.
That's how I found 0.2, 0.3, 0.4, 0.3, 0.4. Any other question?
Hello?
Yes, please.
Yes. Let me just take you behind a bit. I didn't get you clearly when you said that when you're subtracting from the height. Did I get you correctly? You said you subtract, is it 0.5? I didn't get you clearly there.
All right. So for the adjustments, I said if you plus with it as follows: 1 to 5, 6 to 10, 10, 11 to 15, 16 to 20. These are an epitome of a bar chart because there's a space of 1. So you need to adjust them to get an adjusted class. And the rule is you subtract a 0.5 from the lower boundary. So here we're going to have 0.5. Here we're going to have 5.5. Here we're going to have 10.5. And you're going to have 15.5. And the upper boundaries, we're going to add a 0.5. So here we're going to have 5.5. You're going to have a 10.5. Here we're going to have a 15.5. And finally 20.5. Then the frequencies, as they are 4, 6, 8, and 2. And cumulative frequency, can you remind me? How do you come up with the cumulative frequency?
You add 4 plus 6, 10, 18, 20.
All right. Then to calculate the mode means the highest frequency. It's given by L. Let me give you just a shortcut method, D1 over D1 plus D2. People love this one because they don't think too much. The mode is the highest frequency. When you go here, the highest frequency is what? 8. You put FM there. On top of it, F1. Below it, F2. In the same line, the lower boundary is L. The same line with the F1, just got the FC. So the difference between here is called your D1. So what is our difference there? 2. The distance from here to here is D2. What is our distance? 6. The height from here to here to here to here, the height is 5. So using this shortcut formula, what is our L? 10.5. What is our D1? 2 over 2 plus what? 6 times the height of what? 5. All right, so don't touch this guy until you're done with this part here. So divided by 8 is what? 1 point what? 2 times 5 is 10. Divided by 8, what do you get? 1.25, is it? Since you're not calculating, I'm going to assume that is the answer. So
It is 1.25.
11.75. That is how we find the mode. The one you find in your book, L plus what? FM minus what? F1 over what? 2FM minus F1 minus F2 times height. This one is at master's, that one is at undergrad. So what do we have here? 10.5. FM was what? 8. F1 was what? 6. 2 times 8 minus 6 minus 2 times the height of what? 5. You still get 11.75. So let's go through the process again. Mode stands for the highest frequency. So when you identify the highest frequency, that is your FM, which is 8. Above it, F1. Below it, F2. In the same line, so it's like you join a T, an invisible T there. So this is FM, this is F1. 2 and the L. The next to this one is FC. All right. So that is how we find our mode. How do we find a medium?
Mr. Collins, before you proceed, I have a question on the frequency. How did we get the 4682? I'm a bit behind on
Given. This
yeah.
is 4682. These ones are given. What we calculated is the cumulative frequency.
All right, okay, thank you.
All right. Okay. Any other questions? Any other questions, please?
Can you just kindly explain how to find the mode again, just from the beginning?
How do we find?
Sorry. Like just the mode, just from the formula.
All right, the first step, finding the mode. Mode means what?
Most frequent.
Then step one, where do we go? To the frequency and identify the most frequent variable, the highest frequency F. So which one is the highest number in the frequency variable? The column?
8.
8, correct. So 8 is denoted as what? FM.
FM.
We went there. On top of it, F1. Below it,
Mm.
F2. All together. Then the same
Yes.
line, we get the adjusted frequency. The 11 becomes nullified because it wasn't adjusted. We get the 10.5. That is where the job of the adjustment works only, and in drawing the histogram. Then next to the FC, we have what? F1, we have FC. So let's enumerate what we have. We have our height. How do we find the height? The difference in the what? Even the adjusted or unadjusted difference in here. Now, Papa, don't subtract them like this. It's always safe to subtract them in this, whether from this side or from this side, the boundaries. And then what else? Our FM, 8. Our F1, above, which was 6. Our FC is in the same line with F1. So 6 adjusted to the 6 is 10. Of course, it's not usually like that, but I've just summarized it for you like that so that you don't think so much. F2 is what? 2. 2. Our N is 20. So the formula for the mode is simply as follows: L plus FM minus F1 over 2FM minus F1 minus F2 times the height. And the median is simply given by L plus N over 2 minus FC over FM times the height. So these are the two formulas that you use given the data that has been given on top. So what remains is just a matter of you substituting appropriately. Any questions at this point?
Mr. Collins.
Yes, sir.
I followed you up to here. Yes, I followed you up to here. There's a point that you did mention to say when we're getting the height, just maybe kind of repeat what you said, that we should not use something that you did mention when getting the height.
So the class width usually, ideally, it is a difference between the lower boundary and the upper boundary. But sometimes it doesn't work because you haven't adjusted it. 5 minus 1, you get a 4. But if you adjust it, 5.5 minus 0.5, you get 5, the correct height. So I'm saying if you don't know whether the data is adjusted or not adjusted, it's better you just get the differences between the boundaries. 10 minus 5 or 15 minus any can select any two boundaries. 16 minus 11 is still 5. It always be the same in this way, whether it's adjusted or not.
Oh, okay, thank you.
All right.
Okay, so another question is just there on the classes. If it was 1 to 5, and then 5 to 10, then 10 to 11, were we going to adjust the classes, or we're just going to get them as they are?
Okay, there's a question there.
Yes, we were going to adjust them.
He's asking if we had 1, 0 to 10, 10 to 20, 20 to 30. We adjust such a data set.
No.
Why? Because numbers are already the same, they're already adjusted.
Exactly.
Is that clear? All right. Can we proceed?
Yes.
None of you is dropping it.
Not yet.
There's a test tomorrow, so I don't think we can drop anytime soon.
It's anxiety. So now we go to calculate the mean and the variance and the standard deviation. So we have to calculate the midpoint. So how do we find the midpoint? Find the midpoint and square it. And also find the frequency of x. And also find the frequency of fx squared.
Can I start with the
Who wants to try?
midpoint?
Midpoint.
Can I start with the midpoint?
Yes.
Hello?
Yes, please, you can lead us through.
Okay, I want to try. We can calculate by adding 1 plus 5 divided by 2.
1 plus 5 divided by 2, which is 3. Correct.
6 plus 10 divided by 2.
8 to get 9.
Oh, okay, I wanted to finish. Okay. All right.
Then here, x. So 4 times 3 is 12. Then again 4, 9,
Square.
36. The mistake people make is to square these to get that. Don't do that. You always start from 4. 4 times 3, 12. Again 4 times 9, 36. So let's start the ladies here and the gents there and everyone here. Let's finish row by row. Ladies.
6 plus 10 divided by 2. Is equal to 8.
Yes, continue, ladies. Then square it.
64.
Then here.
We multiply 8 by 6.
64.
So multiply 6 times what? 8, which is what?
8.
42.
48.
48 or 42?
48.
48, okay. Then here.
We square root.
Square the 48. Is it
384.
How did you get 384?
You square the x, you multiply by frequency, which is 6.
Correct. 6 times 64. Don't square this guy. Gents, let's continue here.
13.
13. Okay. Now, can you see the format here? The height is 5. It is also consistent in the midpoint. There's a difference of 5 here. Let's add a 5 there, meaning even if I don't calculate there, my next figure will be 18, just to give you a hint. All right. Then what do you have here?
104.
169, then what do you have?
104.
104, then
845.
it's 845. 840 what?
5.
You multiplied 8 times 169.
Just confirm.
It doesn't seem correct to me.
Sorry. 1352.
All right. 52. Okay, here, everyone.
Three 24.
324.
24.
Okay. 324. Then
360.
360. Then here. Is it this?
No. All 360. No, I thought it's supposed to be 36.
36.
Yes.
All right. Okay. Now you only total up where there's an F. Okay. But this is not relevant to total up. So here, the total is our N, which is 20. What's the total here and here? Quickly.
$164.
164. And the other part.
$1772.
So how do you find the mean?
Mr. Collins, sorry, I'm a bit behind.
Uh-huh.
How were we getting the 36, 384, 1,352?
Okay,
Are
so
we squaring the FX?
column 2, column 3, column 4, column 5. How are we finding column
On column 5?
Column 3? You square this. Column 4, which is simply column 1 times column 2. Column 4 is also column 1 times column 3.
Oh, okay.
Any other questions? The mean summation of fx over n. So 164 over 20. What do we get?
8.2.
8.2. All right. Who knows? Who can give us a form of the variance? Group data. Variance is given by what? summation of fx
fx squared minus fx to the power 2 over n, everything over
Divided
n
by
minus
n.
1.
Okay, correct. So we had our fx squared as what? 1772 and 164. 1772, 164. So the big figure comes here. 164 to the power 2 over 20. Everything over 20 minus 1. Are we together?
Yes.
So help me evaluate quickly. We start from here. Evaluate this part here first. 164 squared over 20. What do we get? Quickly.
1,344.8.
Okay. 1344.8. Then we subtract it from 1772 equals, then divide by 19. Please, your calculator is in board mass. If you do it directly, the first divide in there and there to give you a wrong figure. So be careful. 1772 minus 1344.8, then you press equals. And that's when you divide by 19.
22.48.
The final answer 22.48. So this,
48.
I guess.
Yes, like that.
So this is variance. So when you square root it, put the standard deviation. Please, people mistake square rooting and squaring. You need to learn the calculator. That computer is usually abused. So what's the square root of 22.48?
4.7.
4.74.
4.74. Correct. Then how do you find the coefficient of variation? CV, the standard deviation over the mean times 100. So we found 4.74. The mean was what? 8.2. Times 100. What do we get?
$57.82.
57.82. All right.
Sorry, let me see how you've gotten the x bar. The x bar. The 8.2, how do you find it?
8.2, we found summation of fx, which is 164, divided by n, which is 20. That's how we found 8.2.
Okay.
All right. What did you find? What did you get?
Then it's supposed to be 57.80, not 82.
Okay, it's within range. It's okay. All right. Then the coefficient of skewness, since we had calculated the median, so it is 3, mean minus median. I just showed you the formula, but I'm not going to calculate this one. I'll just explain. So if your mean is more than the median, you say it is skewed to the right. In short, if you get a positive answer, it's skewed to the right. If you got a negative answer, it is skewed to the left. Skewed means what? Bending. Skewed to the right looks like this. Skewed to the left looks like that. If you get a 0, it is normally distributed. Looks like this. All right. So we had discussed how to draw the histogram. And I must make mention that the point that touches the midpoints of the histogram is called an ogive. So if you had the histogram drawn like this, an ogive simply touches the midpoints here, 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 and that's called an ogive. Okay, so I'm just going to bring my question here. I'm not going to solve it. I just want to see what questions you may have or challenges you could have for such a question. I mean, straightforward. Median, standard deviation. Construct an ogive. So this is the walkover question. All right. Joseph and your team, you can see that, right? I want you to relate this. And understand what is happening there. All right, so let me go to random variables. There are two types of random variables. There's what we call the discrete, and there's what we call the continuous.
Mr. Collins, sorry, before you proceed, can I see the curve for the ogive on the previous?
Simply the midpoint of the histogram.
Okay. All right. Okay. Thank you.
So if we're dealing with random variables, this is one of the easiest.
Hello, sir.
Yes, sir.
Mr. Collins. Yes. So what did you say? Like when we are told to construct the ogive, you just draw it like the way you drew it, or
yes, just draw the histogram and meet the midpoints. Just connect the midpoints.
Let me just go back to the graph so that we just see.
So the midpoint is here. Midpoint is there. Midpoint is there. Just connect these.
If we are asked to say, yes, if you did mention something like if it's bending to the left and bending to the right, it's either it's bending to the right, or if it's at 0, then it's normal. So can they at times tell you to say what kind of the graph is? Yeah, it is, or it's just to draw like that.
They'll ask you to comment on the skewness. So the skewness always moves with the comment. So if you get a positive answer, just comment to say that the distribution is skewed to the right. If you get a negative answer, you say the distribution is skewed to the left. So this is the spelling for skewed. That's all.
Okay, no, thank you.
All right. So random variables, we have continuous and discrete, just as we have qualitative and quantitative data. Qualitative data is categorical data, which measures types and categories and is subdivided into nominal and ordinal. Nominal is discrete and ordinal is kind of continuous. When you're dealing with nominal data, we're dealing with distinctive information. For instance, place of birth. You're born in Mazabuka, you're born in Lusaka. You can be born in both. Your gender, either male or female, that is qualitative, nominal. But if you're dealing with ordinal data, it has shades of intersection. For instance, what tribe are you? I'm half Bemba, half Tonga. What race are you? I'm a Caucasian, okay, I'm African American. Then we also have quantitative data, which is either continuous or discrete. So if we're dealing with quantitative data, looking at quantifiable information, which is measurable into units. So if we're dealing with discrete, we're looking at countable numbers of values. They have no integers or fractions. They are whole numbers, in short, like the number of times you attended class, the number of children you have. You can't have 2.5 children, just 2. But for quantitative, continuous, you have integers, fractions. Your weight is 7.5 kgs. Your the liquid that you have is 2.78 liters. All right, so just a brief preamble of the kind of data we're discussing. In this case, we're discussing the discrete random variables. So the values of X do not have fractions. They have whole figures like 1, 2, 3, 4. And they'll give you the probabilities. Probability maybe 0.5, 0.1, 0.2, and 0.2 again. So now they ask you to find 2 things, the mean and the variance. I don't confuse the mean for descriptive statistics. Here the mean is simply multiply these 2 here. This times that is 0.5. This times that is 0.2. This times that is 0.6. This times that is 0.8. And then when you total up, we're going to get
2.1.
2.1. Thank you. So this is what we call our mean or expected value or expectation. So sometimes the examiner just put E and X inside. People mistake this one for summation of X. They add up this. Please, these are 2 different things. When you total up there, it's 2.1. Chapel. Then when you square these figures here, the values of X, here we have 1, 4, 9, and 16. You multiply by the probabilities. Have 1 times 0.5, 0.5. 4 times 0.4, 0.4. 4 by 0.1. 9 times 0.2, 1.8. 16 by 0.2, 3.2. Okay. So let's total up in this column.
4.9.
Oh, great, 4.9. All right. Are we together so far?
Yes, we are.
Yes.
All right, there's no one behind. I'm glad. So if I want, I can call this A and B. A is called our mean. Then our variance is simply b minus a squared. So what is our b? 4.9. What is our a? 2.1. So 2.1 squared from 4.9, what do we get?
Mr. Collins,
Yes,
for the total in column B, it's 5.9, not 4.9.
okay, thank you. 5.9. All right. So 5.9 minus 2.1 squared. What do we get?
One point four nine.
1.49.
1.49. All right. 1.49. And then we square root it. We call this a standard deviation. So what's the square root of 1.49?
1.2.
1.22.
1.22. Correct. Then they can ask you what's the probability x is greater than 2? Which numbers are greater than 2? 3 and 4. So probability of 3 plus probability of 4. What is the probability of 3? 0.2. What's the probability of 4? So 0.2, right? So in total up we get 0.4. If they ask find the probability at least 2. So you start from 2, 3, and 4, you add all these. So 0.1 plus 0.2 plus 0.2 is 0.5. About the probability less than 2, which numbers are less than 2 in the values of x? It's just a probability of 1. X is equal to 1. So what's the probability for x is equal to 1? 0.5. About probability at most 3. At most means that number and below. So 3, 2, and 1. We add all these. So you get 0.8. All right. So let's look at an example type of a question. A project has the following projected profits in its second year of trading. So we have the profits and the probabilities. Okay. So what is the probability that the organization will realize a profit in its second year of operation? Find the expected profit for the second year. Calculate the standard deviations. So this is basically what we're just from doing. It does just come in an applied perspective. Okay. So what is the probability that will make a profit? So this is a loss here. When you add the 50, we're going to have a profit of what? Of 30,000 US dollars. So probability of having a profit is 0.404 plus 0.16, which is 0.20, 20%. Just adding these ones. What is probability that the company will make a loss? What's the probability that the company will make a loss? 0.04. What is the company that will make a profit? I think that the profit.
Hello, Mr. Collins.
Yes, please.
Hello. Yes, sorry, maybe just kindly just repeat on question 1 and 2, how we are finding the figure so that we are able to follow.
What is the probability that the organization will realize a profit for the second year? This whole data is for the second year. So the probability that it will make a loss, it is 0.04. Probability that it will make a profit, it is this plus that plus all these have a profit. So you add 0.16 plus 0.5 plus 0.3. So this is a probability. That's why it's just 2 marks. Just need to add. What is the probability that it will make a loss? Just this part here, 0.04. That's the probability that it will make a profit. All these are profits. Just add this plus that. So to give you 0.96. Probability is simply X is what? Greater than -20. So which numbers are greater than -20? The probability that the profit is what? 50 plus the probability that the profit is what? 60 plus probability that the profit is what? 100. Then you add the probabilities there. So 50 is what? 0.16. 60 is 0.5. And 100 is 0.3. When you add all this, you get 0.96. Is that clear?
Yes, it is.
And find the probability that will make expected profit. That's the mean. So values of X and the probabilities. So here we have -20, we have 50, we have 60, we have 100. And here we have 0.04. In short, just multiply this by that, this by that, this by that, this by that, the total. Are we together? Is
Yes. Yes.
Then the variance, you square this figure first here. X squared, you square it. By the way, if you square -200, -20, you get +400. People were making mistakes of putting -400. Any squared number is always positive. So we square these numbers and multiply by the probabilities. Then we use the formula that we used here, b minus a squared. You find the variance and you square root it. That's why it was carrying more marks. It was carrying 5 marks. All right. This similar came last year's paper, 6 marks. Given the data that shows the number of students taking a deferred exam, 1, 2, up to 6, the probabilities, here we have. So what is the mean? The mean, you just multiply this by that, this by that, this by that, and you total up. The variance and standard deviation, you square these values of X. 1, 4, 9, 16, 25, and 36. Okay, I shared all these solutions in the groups, but I hope you're relating to what I'm just from explaining. I don't literally need to go through to calculating everything. Is it understandable?
Very much.
It's slowly sinking in.
Okay.
Hello, Mr. Collins.
Yes, sir.
You're saying that you shared these solutions.
Yes, I shared in the group, paid up groups. Those in the paid up.
I think I don't seem to have them. I'm just kind of requesting that maybe after class or tomorrow we can share so that I can as well go through them just to familiarize myself.
All right, no problem. So discuss the 2 types of random variables that are used in statistics. What are the 2 types?
Discrete and continuous.
Good, discrete and continuous. Okay. This question is there in the QM Bible. You just go there. Random variables. I think it was just book lifted there. Let's type random variables. You'll see here this. Describe the term random variable in the 2 types. So random variable is an outcome that takes a numerical value as a result of the experiment. There are two types of random variables, continuous, and we also, such as weight. Then we also have discrete, which tallies them, such as a number of, there are no fractions here. And then the very question that we have, how many people deferred an exam? So this is the exact question here. So to find the mean, just compute this and that. So your mean is 3.7. Okay, using the table here, they square this like I did, then multiply this. After squaring this, multiply by the probability. So this is your what? Your B. The A was your mean. So you subtract 16.28 minus a mean 3.7. That is your variance. Standard deviation is square rooted. I hope you are able to relate.
Yes,
Okay.
very much.
All right. So let's go to some basic calculations of mean. All right, so we have been told that a dividend has been declared for 10 chemical companies who found 18%. It was discovered that one of the figures was misread as 22. The correct figure is supposed to be 12. So you need to understand that for ungrouped data, mean is simply found as follows. Summation of x over n. So meaning if we're adding numbers from the first number up to the last number, we divide it by n, should give us the mean. So we are told that we added numbers from the first number, and amongst the numbers that we had, we added 12 until the last number we don't know. When we added these numbers and they were 10, what are we told? That these numbers, there was a 22. The correct figure is supposed to be 12, and our mean was 80 what? 18%. So we actually wrote 22. So here, instead of putting 12, we had put 22. And our mean gave us what? 18%. So what we did, in fact, we had over added our total by 10. So to correct this, we need to subtract the 10. But before we do that, let's find what this whole summation was giving us by cross multiplying this by that. So all these figures here, they were giving us 10 times 18, which is 180. Now, since we overstated by 10, we need to subtract a 10 to create the correct figure, which was 170. So the correct total was supposed to be 170. Then the figures are still 10. So meaning our correct mean was supposed to be 17, not 18%. So I repeat, this array of numbers that we added, one of the numbers we put was supposed to be 12, we put 22, meaning we added a 10 by mistake. So to correct this, we need to subtract a 10. In like manner, if the answer we're supposed to put was 22 and we wrote 12, meaning we subtracted a 10, to correct, we do the opposite. That is what the rule of mathematics says. All right. So this is how we got the mean of 17 here. So the next question was the opposite. We are told that there about a mean of 200 observations was 8. We found that there were numbers that were misread as 92 and 8 instead of 192 and 88. So here we're told that the total in this case was what? There were 200 observations. These 200 observations were giving us a mean of 8. Then the values of X had two figures. One figure was wrongly written as what? 192, and the other one as 8. So 192, 292, the other one was 8. Okay, up to the last number. So the total, when you multiply this one, it's giving us what? 16,000. Now, these two figures that we have in here, 192 was supposed to be 92 was supposed to be 192. Okay. 8 was supposed to be 8. So meaning we understated ourselves here. We had subtracted what? We had subtracted a 10 here. What's the difference between, we had 88 instead? So here we had subtracted an 80, and here we subtracted 100. So we lost how many? 108. So to correct this, we need to add back this 108. But the variable still remain the same, 200. So we're going to get 16,180 divided by 200. So this is supposed to be 80.9 as our mean. So these are basics that you need to understand. All right. These are basics that you need to understand. And then let's go to another question to do with the average. So average looks easy, but people miss it somewhere on the means. Are there any questions before I proceed to something else?
No, it's clear.
It's very clear. Okay, thank you. Are we feeling any better than we came?
Yes, of course.
Yes, yes.
Yes, at least yes, we are getting there. At least something new is coming in our mind.
Yes, we are.
All right, so that's good if we're getting somewhere. There's a question that had to do with basketball players, and one was order by a certain age, and they were replaced. So how do we get the mean? And okay. What was that question about? Where is that question? All right, I found it. Okay, so we're told in this question as follows. Right below, we have ages of players in a basketball team. So these are the ages. And we're told that it was realized that one guy was overaged and he was replaced by a new guy. And after he was replaced by a new guy, we're told that the mean reduced by 1 year. So question is, what was the age of this new player? A very delicate question. Question number 1, who was the oldest here? Let's physically locate him, this guy here. Okay. So let's find the average of these guys here, first of all, before we brought in, whilst this guy is still there. So when you add all this, we get a total of 280. Divided by n, how many are they? they are 10. So these guys, their average is what? 28. Are we together? On that point, are we together?
Yes, we are.
Yes.
So when we replace this guy, our new mean became what? Reduced by 1. So our new mean became what?
27.
So meaning after we remove this guy here. So let's replace this by mean. If we're going to say a summation of x, so we don't know the total. We want to calculate the total there. So we don't know the total here. We're just going to multiply 10 times 27. What do we get?
270.
270. So the sum total after we replace that guy became 270. So it means that the age difference created by the replacement is 280 minus 270, which is what? 10. Is that clear?
10.
Is that clear? But it does not mean that.
Sorry, come again. I think I'm lost there.
I repeat. So as they are, the mean is 28. All right, because we added all this divided by 10. Now, after this guy was replaced, if we remove this 36 guy, the mean would automatically drop to what? To 27, because we're told the mean lowered by what? Mean is same as average, the mean lowered by 1 year. So this became 27. Is that clear?
Yes.
So there's still 10 because this one was just replaced, not removed. So when you multiply 10 times 27, meaning the total with this new young guy introduced will be 270. Is that clear?
Yes.
Yes.
So the difference between the new guy who has been brought and the old guy was removed is 10 years. So to know the age of the new guy, just subtract a 10 from this age. So meaning the new guy was supposed to be 26 years old. So this is what we do. Subtract 1 there and get to 7. 10-year difference. So meaning we subtract the 10 years from the 36. So meaning the new guy is 26 years. Yes.
Okay, thank you.
All right. So you see how these are interrelated. You need to understand the concept behind for you to move in that direction. All right. So we will end here. So that I release you